tile, and we should also be able to name the whole group. So when we look at naming this set, and I think I forgot to copy it onto its own page. So, sorry, I want to be able to write around this and have it on its own page. So when we work with algebra tiles, or when we work with algebraic expressions, which is what we're going to practice building today, we like to start with the bigger things first. So which is bigger, the 1 or the 5? The 5, but would I actually count the 1s and 5s separate from each other? Probably not. Which is bigger, x or x squared? X squared. Would I count x's and x squared separate from each other? Yes! Trap door I set up there for you guys. Guys, we can only combine like terms. And this is why you need to have graph paper out today, is to practice combining our like terms. So when we look at this set, can I get a white background here? Hey, Jane. When we look at this set, and I'm going to do my little picture-in-picture thing, how many x squareds do I need? How many x squareds do I need for this set?
1.
Just 1. And I'm going to put that blue side face up because red is negative. You can sit at the front round table or squeeze in as a third somewhere up. Nobody wanted the round table. I don't know why. It hurts my feelings and probably hurts yours. If anyone wants to come join Jane, she's all alone up here now. How many x's do I need? 6 total, right? There are 2, there's another 1, and another 2. So we need 6 total x's. And again, the blue side face up. 1, 2, 3, 4, 5, 6. How many 5s? 1 5. And then what else?
3 1.
3 1s. But guys, can I combine 5 and 1s? Yes. So that's really 5, 6, 7, 8, right? Any questions on how we laid these tiles out? So guys, this is like the commutative property that tells us we can move things around. Can I lay these out on my desk? Can I push them around to group up things that go together? Yes. If you have any red tiles up, flip them over. We are not looking at red today. Reds are negative. We're trying to keep our life slightly easier and only do positives right now. So if I moved these around and got everything grouped up with its like matching partners, Carolina, how many x squareds did we say?
3.
X squareds?
Oh.
1, and we don't even have to write the 1, but it helps us clarify, hey, there's only 1. Matt, how many x's were there? Yeah, 6 x's. And then our constant, guys, again, constant is numbers we know. Constant, numbers that we know. Say, what is our total of our constants here? Close.
8.
8, 5, 6, 7, 8. Who do we appreciate? Oh, nice. So, this is how we would write the algebraic expression for this set. I would write this down if I was you. Now, if you wrote down x squared plus 2x plus x plus 5 plus x plus 2 plus 2x, is that the same?
Yeah.
Which one do we like better?
The top one.
Yeah, and this is why we combine like terms. But the trapdoor here is you might think the x goes with the x squared. And actually, how these tiles are made kind of makes you think that they go together because they're the same color. But if I count this as 1, does this also count as 1? No. I would need x long and x wide. And actually, if you try to set this up to be x by x, you can't. These tiles were specifically made so that I cannot make a certain number of these equal x squared. It doesn't work like that. These just do not go together with our x squareds. We have to keep our shapes separate from each other. This is what like terms means. Same shape, same size, same power, same letter. Like, it's all got to be the same, right? Or if there's no letters, that's a constant. Try this set with your partner. Get them all out, sort them how they should be sorted, and then write the total of the set. You're going to need graph paper because this is not on our worksheet paper. When you think you have it on your paper, label this number 72. And I want to know what your total area is. You can label that 72 on your graph paper. What is the total of all of them? Now remember, we said our X's are the blue, light blue, but still the blue. If you have purples out, that is wrong. If you have purples out, that is wrong. Arfon, the biggest tiles that we had there, the x squareds, how many did we have? We got 3 of them, right? 1 and 2 and 3. So we have 3 x squareds. I hope we all agreed on that and kind of got that down first. As we moved around our rectangles, Kamal, what amount of x's did we have? Sure? Six x's, because we got 1 here, 2, 3, 4, 5, 6. So plus 6 x's plus our constants. Donna, you want to help me out with our constant values?
You said constants, and that's my answer. Really? 5.
So 5, 10, 15. 18 in total. And guys, you might want to make this note on your paper because Bethany has brought this up. The word I'm saying is constant with a T. They're constant because we know what they are. They're a constant because we know what they are. So, because we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. But the x's, we don't really know what they are. X could be 1. X could be 10. X could be negative, but that gets tricky of like, wait, how do you have a negative length? Remember, X could be negative, maybe not in this situation, but in math, X could be negative. So the other tiles, this our variable is x squared, and this our variable is x, but you are correct. Numbers we do not know, like even though we know the 3 and we know the 6, still these are called variable terms because they vary, right? They change, they vary. That's why variable, they can vary. You guys feel like pros at this?
Yeah.
Think you could like pass a mastery on it?
No.
All right, let's act like this is a mastery. What is the total area of each of the separate sets? Area, just area.
The area is allowed to have x's next to it, right?
x squared, it can have the x's, it can have the constants. So if you need to build it, but you don't have to build it. You might be able to figure out, so this is still 72, but this is B and C, if you really want to know. 72B, 72C. We like to start with the biggest ones. We like to end with the constant. We like to write that last. Right, so we like to end with the constant.
My bad.
Ashley, can you help me with part B? Up here's the one on the left side of the screen. For this, sorry, the left side, because the I know it's tricky because this would not. The one we just did was A, and this is B and that's C. So I think you started on C. Do you want to do this one instead? I mean, you can. I don't care. You want to do that one? Okay, what's over here? Yeah, we don't have to say the one, but it's better if we do. All right, one, Ashley, keep going. Oh, and just one x. And then plus 2, we like to put that constant last.
Oh.
Question or trying to answer? Question or trying to answer?
Oh yeah, I'm trying to answer.
Well, I'm using cards. I'm sorry for the heartbreak. Oh, Lane's not here. Lane, feel better. Get back to school. Or is he on a trip? Where's Lane at?
He's like kind of like.
Let's not guess. Sophia, can you help me with part C? 3x. Sorry, I couldn't hear you.
3x plus 3.
Sweet. So if you guys were able to do both of those, you were essentially able to pass our pop quiz. I don't really do pop quizzes, right? But like, if somebody put this in front of you right now, do you think that you could do area of these tiles?
Yeah.
They're pretty straightforward, right? We're not using the purples, we're not using the greens yet. You might live to regret those words. So since we feel like we're so good at area,
Perimeter.
now we get to do perimeter.
That was not.
Let's go.
So I need you to lay out this set on your table and figure out the perimeter. You might want to draw this on your graph paper. I'll give you a little bit of time. We're figuring out the perimeter of this.
Wait, that's not fun either.
Sure, but you could also just get another blank sheet. Hey, friends, by the way, as we're doing algebra tile work, my blank paper lives either right here. I try to keep this like actual nice computer paper that's not been printed, but down here, actually, I'm going to replace it with my lined paper. So I'm going to move my blank paper up here because we don't use lined paper in this class. If you want blank paper so you can draw the algebra tiles or trace them, just come back here and get blank paper. And I'll put this lined paper down here since nobody cares about lined paper.
How should he do it?
I know, I'm just joking because I'm all about math in here.
I do it.
Finished? Then confer with another group. After you and Raiden both think you're finished, confer with another group.
You were saying. No, I think you're saying.
Now, wait, did you simplify it? Because if you pay attention up on the screen, somebody wrote what they said. I don't know if it's right or wrong, though. And we want to simplify. We want to be as simple as possible. You guys have an answer? Confer with another group, then once another group. Actually, here, confer with Arfon's group, since you guys say you're done also.
Come here, boy.
I did that. Don't
Guys, respect people enough to give them the time to solve these things, because I hear some partners yelling at each other.
No.
But, like, don't tell me. Like, give your partner time to think. Bethany, if I try to look at this entire length, what is it? Or let's break down the individual lengths, then put them together to figure out the entire length.
1x, and 1.
So there's an x here, and x here, and a 1 there. So in total, the length is 2x plus 1. Or you could say x plus 1. Okay, what am I missing, Devin? If we've got the bottom label broken up, the top labeled together, what am I missing? What do you mean the other half? Because I've got X, X, and 1 down here. I don't know what you mean. Oh, the ones! So I got a 1 right here and a 1 right here. Alright, so Luis wrote, or sorry, Leanna, I'm getting all my CPM names mixed up. 2x plus 1 plus 1 plus 1 plus 2x plus 1. Eli, what do you think? Is Leanna correct? They wrote 2x plus 1 plus 1 plus 1 plus 2x plus 1. Leanna wrote this. Say that louder, and y'all stop talking. So then Jonah, but we have a Jana here in 8th grade, wrote 4x plus 4. Is she right? He right? Jonah, Jana, I don't know. Jana's over in 8th grade. Jonah's in this problem. If we clean it up, how many x's total? Well, 2x plus another 2x is 4 x's total. How many constants total? 1, 1, 1, 1, 4.
How you feeling with perimeter?
Oh, you sure? You might live to regret those words.
Lemon squeezy.
All right, find the perimeter of this shape. Bet.
I said currently not hard. Is that better?
Oh, you guys think you're so good. Throwing out the E word.
Sorry.
I don't think you are sorry.
You know what, Rick? I feel like a lot of teachers tell you that. Yeah. Like Miss Hossening and Miss Howard. And shut up. Don't talk about that. I did it. You know, like, this is really not that bad. Yeah. I finished. Dude, I can't see what you do with it. Here.
I should not need to keep. It's just that.
We done. Don't. I want to myself. No.
Brayden,
Yeah. Want me to explain
if
it to
we
you?
look at just the top, if we look at just the top, what is this length?
X plus 2.
X
Plus 2.
2. Questions on how Raiden figured out X plus 2?
No.
If we look at the left, Emery, what is the left?
1x plus 2. Wait, 1. My bad. Bring back
X plus 1, because the extra 1 right here. Are we getting really good at tacking on the extra ones? Hint, hint, nudge, nudge, foreshadowing. Jack, what about this length on the bottom?
X.
Just X. Ooh, now this is where it gets fun. Sam, and you weren't even here yesterday. Well, let's see how well you're picking up what we did. Boom, bada, boom. What is this purple?
2.
A 1 and a 1 and a 1.
Oh, 3.
3 in our corner down here. Or you could just put 1, 1, 1. Right? But we have a 1 right here, a 1 right there, and a 1 right there. Right? So there are 3 down here in this corner. And then on the right-hand side, Sophie. What's this? So then we go to clean up our like terms. Did I start class call on you guys, by the way?
No, you started class on them.
Well, no, I think you were at the pretty big. Yeah, we're back around. I'm going to shuffle here soon because I haven't shuffled in a while. So, Carolina, how many X's in total? 4 X's in total. 1, 2, 3, 4. How many constants in total? Yeah, 2. 1 more. 3 more. 4x plus 6. How you feeling with perimeter?
Do it easier.
Okay.
Lemon squeezy peasy.
Find the perimeter.
Peasy.
Oh,
Oh, this is
of both of these.
Bet.
We just did that.
Perimeter.
My bad.
I need to have this out here.
This is what y'all get for throwing around the keyboard.
You want to go, Hudson?
When Dave and one person in your group ruins it for everyone.
It was so not hard though. Not hard. Stop saying that.
Okay.
Oh wait, I hate this one. It has some weird side to it.
Maybe this was the progression that was planned.
It's almost like Hudson's smart enough to
Talk with your partners.
challenges.
Don't talk to me until you talk with your classmates.
Don't talk to me. Loser level wanna be like
Talk with each other. We got time. Don't worry. We got over 10 minutes.
What?
This is why I like that this lesson was a 2-day lesson. It gives us some breathing space.
Okay, X. This day has been going very slow for me.
Until you got to math.
Slow.
Hey, so just to say it, because I like appreciating you guys, I am so much happier here than sitting on my couch at home recovering it. And like the details don't matter, but like I was here yesterday for only half day because I was like in pain and I don't do well with pain. But guys, y'all are awesome. Like, I love my job. I love getting to work with you guys. Like you're sweet. I also appreciate that you're in this. So those of you asking about, wait, can we use subtraction or negatives? Yes. Yes, that is the right track. Take a couple more minutes and we'll come back together.
Subtraction and negative. Mr. Hudson, if we were to become a teacher, which grade would you recommend?
Well, it depends on your personality. Like, I didn't think middle school was going to be my thing, but then as I started doing some placements in like high school versus middle school, I really liked middle school, like the attitude you guys have. Now, some high schools are really cool and like depending on what you would get to do there, but I think this is the important math. Like, really, I think this math is more important than high school math.
Wait, what? I mean, I guess you're right. But you know, like at the same time, like I feel like no one even remembers half the stuff that teachers teach us in the grade.
I
Not
hope
this.
you remember my half.
I
Forget that half number.
always forget the math. I always remember the math because you know it's important. Like, I know I'm actually gonna need it, right? But like in other classes, I forget so easily.
If your group thinks you're done with one of these, turn to another group and see what they say. Turn to another group and see what they say.
I don't know, I feel like I'm never gonna go back in life and be like, gee, I wish I would have paid more attention in 6th grade social studies.
It all
Or about
relates.
ancient
Like,
China.
it's hard to help you guys see how it all relates, but it all relates to like you just being a human in the world.
Cause like, I know math's important, NVLA is important, but like, I'm a little.
Social studies is very important so we don't repeat the mistakes of our past. Jack! Let's go ahead and grab a seat. Jack! That left side that I have color-coded green, but I feel like I did it slightly wrong. Can you phone a friend? You shouldn't have your phone on you. Sure, you can pass this off if you want. Are you tagging in safe?
Yeah.
Alright.
Basically, what we got here is
You can draw a picture of this too if you want it for your records. Sorry, go ahead. I don't want the answer. I want one side at a time.
alright. So yeah, it's kind of hard to say. Alright, so this side on the right, the blue side.
Loose. Let's start with the green side.
Alright, green side.
Because if people are struggling to understand it, this will help them understand.
That is x.
Look up here.
This x minus 1.
Why?
Because the one right there, that guy's blocking the way.
So what I highlighted would be X. But do we have all of it? No, we need to get rid of this. And what that does to us for that left edge is it says, wait a minute, this, I need to minus 1. So that is really X minus 1. Now, I know what some of you might be thinking. Look up here. I guarantee at least one of you is thinking, well, I mean, if I count this, then I have X. You're right. But don't complicate it like that. Don't make your brain think about, wait, I already counted that because I put it. No. Trust me. This is X minus 1 because we're missing that. And then let's keep going. What is this?
That's 3.
That's 3, right? Break this up. Make your life easier. What is this across the bottom?
X plus 1.
X. Then we have another 1. So you can either do X plus 1 or you could just put an X and put a 1. Then the blue edge. So hold on, because I want to see if other people are getting this too. Raiden, the blue edge. How long is that?
Wouldn't it just be the same as like the green one since it's like they're both X, but there's 1 in it, so it's X minus 1.
This would have been X, like Raiden said, but there's a 1 chopping out 1 of its length. So that is really X minus 1. So for this, hey, hold up. That's both of these pieces. This top piece and this piece, both of those together are X minus 1. But wait.
Don't we really just do 2x minus 2?
You're trying to combine stuff. We're not even done with our walk. Like, we're still taking our walk. What is this length? 3. And then, I'm running out of colors. What is this length?
X plus 1.
X plus 1. Now, Emery, gather up all your like terms. How many X's? Yeah, we don't need to think about the minus 1s or plus 1s or any of it. Just the X's. Well, I got 1 here, 1 there, so that's 2, 3, 4. So we have 4 X's. Before we think about anything else, 4X. Then, guys, I would do positive separate from negative. I would grab your positives, then do your negatives. So let's get all of our positives. Positive 1. So total 4, 5, 6, 7, 8. So we got 8, but then minus. Okay, minus 1. Another minus, so minus 2. 8 minus 2. 6. So 4x plus 6.
Yes, sir.
So here's the challenge question.
Nope.
And the last thing we're going to do today. What is the length of this and this together? So with your partners, we got 5 minutes left. Try to figure out the total perimeter here. But the first thing that you like, the trickiest part is probably what is the length of those?
X minus 3.
All right, dive in.
X
first.
3. Wait, is it X minus 3?
Talk with your partner.
Josh is not free, my girl.
Yeah, it will be X minus 3. Yeah.
Why are you like talking with a weird accent?
Because she's Emery. What do you think?
Yeah, but it seems like it could be potentially offensive.
But to who?
A cowboy. My grandpa's a cowboy. I mean, really not a boy. But you know, cowboy and cowman, there's a difference. Cow old man. Nobody actually wears like
Alright,
a
sir.
hat all the
Gotta
time.
calm down.
He wears spurs everywhere. You know why he wears spurs everywhere?
You know what the point of spurs is?
Yeah, to kick horses when they're not listening. I'm a horse rider, Hudson.
I know.
I don't think that's polite. I think we should talk gently to the horses and say, "Excuse me, Mr. Who is Mr. Ed?" You have no idea what I'm talking about, do you? Look up Mr. Ed. He was, maybe if we had time at the end of class, he was a talking horse in a TV show. Like, way back, like before I was born.
Well, it's just
So it's really old.
Hudson. You gotta understand that we don't kick them like really harshly. We like they're really thick skinned. So when we think that
Yeah,
it's
they
like,
barely.
ow, my leg, it's
I
like
like how when you have to redo their shoes, you like carve, like their hooves are like our toenails. You don't feel it, right?
yeah.
All right, Eli, I'm going too deep down the rabbit hole of talking about horses.
We'll
I
talk
will
about it
let
later.
you decide what part of this you want to give me. You can start by giving me the bright green part, or you can start somewhere else. But we're going to start taking a walk. Eli says that this should be, I guess I should probably go a little bit darker, x minus 3. Do we agree, disagree, or we're not sure? I agree with Eli. Because this would be x, right? This is x. On the bottom, that is x. So then, if I look at how long is left after I take away 1, that was minus 1. Take away another 1, there's minus 2. Take away another 1, there's minus 3. We're left with x minus 3. But wait! This is where like mistakes are bound to happen. Well, not bound to happen. How long are we in here? 1, 2, 3, 4, 5, 6, 7. Okay, so we got plus 7 in here. But then Carolina, how long is this? Ooh, because we're missing this 2. So x minus 2. How long is this? Another x minus 2. I don't have a lot of board space, so I think I'm going to have to start combining things. Anybody, how long is this? How long is this? How long is this? So you might as well say 3 more x's. I'm still missing some tops and bottoms, right? So 1, 2, 3, 4. So plus 4 more. Let's make sure we get all this down here. So I got my yellows. I need to bring down my purple. I know that's hard to see. I need to bring down my blue. My plus 7. And I need to bring down my green, x minus 3. Put all that together.
I got you.
We got the x minus 2s. Yeah, I wrote those down here. That's why I color coded to keep things. And my blue, I just went from dark blue to light blue. But I think I got it all. Matt, how many x's in total?
Ow! You okay?
You can stab yourself quietly.
Mr. Hudson.
Well, you don't need to announce it to the class. You did it to yourself. So, work with me. How many x's here? 3, 4, 5. So there are 6 x's. Plus, Donna, what about our constants? Ooh, this is convenient. What happens if I do that with these? Yeah, the positive 4 and the 2 negative 2s, those cancel. So 7 minus 3. So this would actually have a perimeter of 6x plus 4. That's all the time we got. Great work today, guys. Do your homework. 431 is due Friday. Guys, you only have 2 homeworks due this week. Come on, friends. Catch up. You got work time in science. Get caught up.
Oh, really?
That's what I've been told.
Yay!
Hold up, let me pause.